Okay, now we'll be discussing about the graph data structure. If you remember the very basic classification of data structure, they were classified into two types, primitive and non-primitive. And there again we had classification called linear and non-linear data structure. In linear data structures, we have studied about arrays, stack, queues, and linked list. In non-linear data structures, the two main types of data structures are trees and graphs. So we have seen the tree data structure. Now the very last type of data structure is called as graph. So we'll be discussing about graph in this class. So we must have used a graph in our day-to-day lives. That is basically what it is. It is very similar to the mathematical graph. That means if you have studied the DMS subject, there will be having graph. Basically what graph consists of? It consists of some nodes and some edges. Some nodes and edges, and the combination of the nodes and edges is termed as a graph. And technically those nodes, we call them as vertices. Technically the nodes are called as vertices. Vertices are nothing but the nodes. Vertices are nothing but the nodes of the graph. I'll just try to show here. Right, the graph data structure. So it is nothing but the collection of vertices and the edges, and it is having the fundamental applications like computer network analysis, travel application, chip designing, and gaming, and so on. For example, network analysis, to find the shortest route from the source node to the destination node, we make use of the graph data structure. Because to reach from one city to another city, for example, if you want to travel from Gadag to Bangalore, so there are multiple routes, multiple paths what you can follow. You will get multiple cities in between. But traveling across those multiple cities, which will be feasible path for you? So that selection will be helpful only when we have graph in our hand. That is graph of all the cities connected by the edges. So edges in this case can be simulated with the roads connecting two cities. So that is how we can make use of the graph. So if you can consider one example graph, so the formal definition for the graph is a set, it consists of two entities basically, the vertices and the edges. Vertices are denoted by the set called V, that is V of vertices or nodes. Vertex or node both will be used in programming. Vertex or node, they will be used interchangeably in the programming language. So all these are nodes which are stored in a set called V. For example, in this given graph, the set of, for example, there can be any n number of nodes in a graph, V1, V2, V3, so on up to Vn. So that means there are n number of nodes in a tree or n number of vertices in a tree, in a graph. So graph is also one type of tree only. Graph is also one type of tree only. We'll come to know later. Then one set is set of nodes, and when we have some nodes, there must be some connectivity among those two nodes. The two nodes must be connected with each other, because when there is no connectivity between two nodes, we cannot transfer the data from one node to another node. If there is no connectivity between two cities, you cannot reach from one city to another city. So next entity in the graph is a set of edges which is denoted by E. Set of edges which is denoted by E, and they are also called as arcs. Arcs or edges, and they are denoted by the set E, and that is there can be n number of edges, E1, E2, so on up to En. There can be n number of edges in a graph and there can be n number of vertices in a graph. So what basically a graph is? Graph is a collection of nodes and edges, collection of vertices and arcs. So any term you can use. So here how we define graph? Graph is defined as G equal to V comma E. Graph is defined as G equal to V comma E. That means it is a collection of some vertices and some edges. Collection of some vertices and some edges. So this is one example graph. That is figure 9.1 shows one example graph. In this example graph, we have some vertices and some edges. So what are the vertices or nodes present in this? The nodes present in this graph are V1, V2, V3, V4 and V5. That means how many nodes are there in this one? In this graph, number of nodes is 5. In this graph, number of nodes present is 5. Now number of edges. How many edges are there? 1, 2, 3, 4 and 5. There are 5 edges in this graph. So this is a graph which consists of 5 nodes or 5 vertices and 5 edges. 5 vertices and 5 edges. Right? So now how the edge is defined? How the edge is defined? An edge is always defined by the combination of 2 vertices. An edge is always defined by the combination of 2 vertices. For example, this edge is defined something like this, that is E1 here. E1 is a name given for that, but how it is defined? V1, V2. That means E1 is an edge joining 2 vertices V1 and V2. Similarly, E2 is an edge joining V2 and V3. E5 is an edge joining V3 and V5. E3 is an edge joining V3 and V4. That is how the edge is defined. So edge is always defined by combination of 2 vertices. So generic formula is E is defined as U comma V, where E is an edge which is connecting 2 vertices U and V. E is an edge connecting 2 nodes U and V. Now there are 2 types of graph what we have usually, directed graph or undirected graph. Directed graph in the sense there will be some arrow or direction from one node to another node. But here in this case, whatever we are considering now is an undirected graph. That means if there is some arrow mark like this, what it indicates here is E2 is an edge from V2 to V3. You cannot go from V3 to V2. That means one way. You are allowed to go only from Gadag to Hubli. You are not allowed to travel back from Hubli to Gadag. So that is one way connection, or you can call it as one way path from one node to another node if it is a directed. But whatever graph we are studying, it is an undirected graph. Undirected in the sense there is no direction. You are free to consider this edge as V2 to V3 as well as V3 to V2. That means E2 has both. It can denote the edge in both the directions. That is either V2 comma V3, or edge 2 can also be like this, V3 comma V2. That is both way. There is no fixed direction. There is no restriction that you have to go in this direction only. Similarly, this edge V1 to V2 or V2 to V1. So both are defined by the E1. So that is the case when we have the undirected graph. That's what I told. This is what is an undirected graph, and in this undirected graph, the edge is representing in both the ways. That is from both the directions. Now, if there are some graphs in which there is a direction, and that is called as directed graph or digraph. Directed graph or digraph. This is what is an example for the digraph or directed graph. So in the directed graph, we will be having fixed direction from one node to another node. So what is that fixed direction? Say for example, this edge E1. How E1 is defined here? E1 is an edge. So which is defined something like this. What is that? V1 to V2. That is V1 comma V2. And this edge one we cannot define it like this. V2 comma V1. No, this is not allowed. Why? Because it is a directed graph. It is a directed edge. E1 is a directed edge. Only the path is possible from V1 to V2. You cannot come from V2 to V1. So that is not allowed. That is not allowed. So this is a correct edge, whereas this is not an edge. But if it is an undirected graph, then it is possible in both the directions. Similarly, one more edge E2 here. What is that one more edge? E2 edge is defined from V2 to V3. From vertex V2 to vertex V3. That is one more edge. Similarly, if you consider E4, E4 is one more edge which is defined from V1 to V4 because it is a directed graph. And number of nodes in this graph is 5 and number of edges in this graph is also 5. Now for this given graph, so this is how the vertices and edges are denoted here. How many vertices we have? V1 to V5. So V1, V2, V3, V4 and V5 are the vertices present in this directed graph. Now edges, what are the possible edges? Possible edges are V1 to V2, that is edge E1. It is V1 to V2. Next edge E2. E2 is what? V2 to V3. This is another edge. E3, V4 to V3. That is V4 to V3 is one edge. Then V1 to V4 is another edge. V1 to V4 is another edge. And V3 to V5 is another edge. V3 to V5 is another edge. So the only difference between directed graph and undirected graph is, in case of undirected graph, the edge can be assumed in both the directions. Whereas in case of directed graph, we are allowed or we are supposed to assume the edge only in one direction. That is as per the direction of the edge. As per the direction of the edge. Now the different terminologies what we consider in case of graph. Like if you remember while discussing about tree data structure, we had studied about some of the basic definitions or basic notations what we use throughout the graph discussions. So you can call them as some of the definitions, right? So the first definition, we know now what is a node, vertex and what is a edge and graph. We know these terms. By combination of all those terms, now we will define some other key terms, Adjacent node. So as we can see here is adjacent node, as the name itself says, neighboring node, immediately neighboring node. If there is an edge called E of V, UV, that means it is an edge from U to V. So what this basically represents here is we have an edge from node U to node V. There is one edge. If E of U, this is what? Edge. Represents an edge between U and V vertices, then both U and V are called as adjacent to each other. That means if these two nodes are directly connected, there is an edge from U to V, then they are called as adjacent to each other. U and V are treated as adjacent to each other. For example, that means U is adjacent to V, U is adjacent to V and V is adjacent to U. That's it. Both are adjacent to each other. That means if there is a direct edge from one node to another node, then they are treated as adjacent to each other. That is one terminology. Another terminology is predecessor node. Predecessor node and successor node. That is just the source is called source to destination. We consider two nodes to define this. For example, in this given graph, if E of UV is an directed edge from U to V, directed edge. So it is an undirected graph. Now I will make it as directed edge. That is edge, there must be an edge from vertex U to vertex V. And what type of edge? Directed edge. So U to V. Now I have created direction. Earlier graph was different. Now it is different. There is a direction from U to V. In this case, what we call here is U is predecessor of V. U is predecessor of V. That means U is coming first, then V will come. Because what it is an edge. What type of edge it is? It is a directed edge. It is a directed edge. So U is predecessor of V. Similarly, another term, successor. In the same edge UV, if it is a directed edge from U to V, then V is successor of U. Here in this graph, V is successor of U. That means V appears after U. V appears after U. That is what is another terminology. Degree. So degree, what we have studied in tree, that is same. Degree of a vertex is basically the number of edges connected to a vertex. That means how many edges are joining to that particular vertex. So that is called as degree of a vertex. How many nodes are connected to a vertex. For example, in the above graph, whatever we have studied, the degree of V3, vertex 3 is 3. Degree of vertex 3 is 3. Right? So this is what is the graph what we have studied. One second. All right. In this given graph, the degree of in figure 9.1 they have considered. Okay, both you can consider 9.1 and 9.2. This is 9.2. I'll try to take them here. Because once we have those nodes, that tree here will be easy for the explanation. Okay. In figure 9.1, the degree of vertex V3 is 3. So let us go to figure 9.1. So what is degree of vertex V3 here? How many edges are joining or reaching to V3? For node 3, the number of edges which are reaching is 1, 2, and 3. So that means degree of V3 is 3 here. What is degree of V5? How many edges are joining to V5? So for V5, the number of edges is 1. So degree of V5 is 1. Similarly, degree of V4 is 2 because 2 nodes are joining there. This is one edge and this is another edge. So 2 edges are joining to V4. So basically what degree indicates? The number of edges which are joining to a particular node is going to represent the degree. Similarly, in this diagram, degree of V2 is how much? Degree of V2 is 2 because there are two edges which are merging there, E1 and E2. That is what is degree of a node. In degree, as the name itself says, in degree, that is number of nodes which are joining from the outside to that node, that is called as in degree, and it is represented for the directed graph only. So in a directed graph, in degree of a vertex or in degree of any node is the number of edges ending at that vertex. The number of edges ending at that vertex, that is what is in degree. That means how many nodes are reaching to that particular, how many edges are reaching to that particular node, that is called as in degree. For example, in degree for V3, in this example, in degree of V3 is how much? In degree of V3 is two edges are ending there, that is E2 and E3 are edging. So in degree is 2. In degree of V5 is 1. In degree of V4 is 1, right? In degree of V2 is 1 because the number of nodes which are joining there is defining the in degree. Similarly, out degree. So out degree is another terminology. So what out degree indicates? Out degree indicates in a directed graph, out degree of any given node or any vertex is the number of edges beginning at that vertex. How many edges are starting from that node, that is called as out degree. For example, out degree of V3. Out degree of V3. How many edges are starting from V3? That is 1. Out degree of V4. Out degree of V4 is also 1 because only one node is starting from V4. From V4 one node is going out. Its out degree is 1 and its in degree is also 1. That is one simple notation term. In degree and out degree. Now let us say path. Another definition terminology is path. So as the name itself says, it is a collection of node, a sequence of vertices which are adjacent to each other, and they will be followed to reach from one node to another node. To reach from one node to another node. For example, in figure 9.2, V1 to V5 is one possible path. They can take any other example. V1 to V5. That means what is the sample path in this case here is, if you want to reach from node V1 to V5, what is the path? First you have to go from V1 to V2. Then you go from V2 to V3. Then you go from V3 to V4. So this is one possible path. What is that path? V1, V2, then V3 and then V5. V1, V2, V3 and V5. That is V1, V2, V3 and V5, one possible path in case of directed graph. So that is possible in case of undirected graph also. So there can be multiple paths what you follow. So basically what path indicates, it's collection of vertices. They will be followed in sequence to reach from one node to another node. So cycle as the name itself says, it is a path. It is one example path which starts and ends at the same vertex. Example path which starts and ends at the same vertex. In this example, cycle cannot be shown here. That is, cycle is an entity in which the path starts and ends at the same vertex. For example, 1, 2, 3 and 4. 1, 2, 3 and 4. This is one example of cycle. What is cycle example here is 1 to 2, 2 to 3, 3 to 4 and 4 to 5 is an example of a cycle. So it is starting and ending at the same vertex, then it is called as a cycle. That is also a path only, but it is going to start and end at the same vertex. Loop, the name itself says, it is an edge whose endpoints are same. That is, it is starting and ending at the same node. That is called as a loop. For example, in this graph, 1, 2, 3 and 4, if you consider this as a graph, if there is one edge which is starting and ending at the same node, that is called as a loop. It is an loop, and sometimes it is also called as a self loop, which starts and ends at the same node. Weight. So in case of graph, we can assign some weights or values to the edges. So they are called as it is some non-negative number that is assigned to an edge. So that is basically that is usually indicated, that is usually used to indicate the length of the path, which has to be length of the path or cost of the path. For example, the weight you can specify something like this. If you are going from Gadag to Hubli, and this is what is edge. So this edge you can write something like this. What it indicates here is 56 kilometers. What it indicates, it is the distance from the distance from Gadag to Hubli, and that is what is its weight. You can give any other terminology you can use. Basically, some non-negative number will be assigned. What is an order? Order of a graph is the number of vertices contained in the graph. That is how many vertices are present in the graph. That is what is order. For example, for this graph, how many vertices are there? 4 vertices. That means order is 4. In this graph, 2 vertices are there or 2 nodes are there. Order is 2. Labeled graph. It is a graph that has labeled edges. That means all the edges are given some proper labeling. Then it is called as a labeled graph. So these are examples of the labeled graph, whatever we have said. Because all the edges are labeled here with proper identification is given for each and every label. Weighted graph, a graph in which every edge is assigned with weight, that is called as a weighted graph. That means a graph containing weight is called as a weighted graph. That's it. What is a weight? Some non-negative number assigned to an edge. And if there is a graph which is containing the weighted edges, then it is called as a weighted graph. Connected graph. What connected graph indicates? It is an undirected graph in which there is a path between each pair of nodes. There is a path between each pair of nodes. That is called as connected graph. So what is connected graph? You can reach from one node to every other node. That is called as a connected graph. That means there is a connectivity from one node to another node. There is a connectivity from one node to another node, A, B, C. So this is one graph in which there is connectivity from one node to another node. Right? If you consider these 3 nodes, now I will try to draw it like this. So every node is connected. That means if you start from B, you can go to C, B to A to C. If you start from C, you can go to A and then you can also go to B. From C you can reach both the nodes, from A you can reach both the nodes, from B you can reach both the nodes. So this is an example for connected graph. There must be connectivity. Assume in this graph, if there is some node called D, something like this, which is isolated, for which there is no edge to reach, then the graph becomes not connected. It is disconnected graph. And what is strongly connected? The strongly connected graph is one, that is in case of direct graph, in which there is a route between each pair of nodes. There is a route between each pair of nodes. Every pair of nodes, from one to one, there is a connectivity. Then it is called as strongly connected. For example, it is from here to here we have edge. From C to A we have edge. Then here as we have considered only 3 nodes, I should consider more number of nodes for that. Okay, I can draw it here. 1, 2, 3, 4. 1, 2, 3, 4. There is every node is connected with each and every other node. Yes, that's it. From 1 you can go to all the nodes. From 2 you can go to all the nodes. From 3 you can go to all the nodes. From 4 you can go to all the nodes. So that is called as strongly connected. Complete graph. What is complete graph? It is also an undirected graph in which there is a direct edge between each pair of nodes. That is a direct edge from. One second. See, whatever example I gave here, this is an example for complete graph. Because see here, I just didn't observe that this is a directed graph. Whereas in undirected graph, in an undirected graph, there is a direct edge between each pair of nodes. That is what is complete graph. So this is what is complete graph. 1 second. Right? This is what is an example for complete graph. Whereas strongly connected means in a directed graph, there is a route between each pair of nodes. There is a route between each pair of nodes. That means from B to C you can go, then from C to B. It is possible. From C to A, then from A to C. B to A, from A to B. That means there is direction. That means both the way you can traverse. Both the way you can traverse, and there are directions, possible movements from one node to another node in both the directions. Tree, it is a connected graph with no cycles. That is what is a tree. As I said, tree and graph. Graph is one type of tree only. Right. So this was the introduction about the graph data structure and some of the terminologies what we have studied about the graph. So in the next class we'll be discussing about how to implement the graph by using adjacency list and by using adjacency matrix and adjacency list.